Another mole questions. The reaction is given. Sodium hydrogen carbonate is heated and it forms three products. So heating sodium hydrogen carbonate, you get sodium carbonate, water, and carbon dioxide. Name the type of reaction. So this is actually decomposition reaction. So we will be calling it as decomposition here. The next part is related to the number of moles. So they are asking calculate the volume of the carbon dioxide produced at room temperature when the pressure when 12.6 gram of sodium hydrogen carbonate is heated using the following steps. So first to determine the mass of 1 mole of sodium hydrogen carbonate. Now how to calculate the relative molecular mass of sodium hydrogen carbonate. So if we calculate that, sodium 23, atomic mass 23, hydrogen 1, carbon 12 plus oxygen 16 multiplied by 3, and the answer will be 84. So molar mass, this molar mass is what? Mass of 1 mole. So mass of 1 mole is equal to molar mass, which is equal to 84 in case of sodium hydrogen carbonate. The second step says calculate the number of moles of sodium hydrogen carbonate used. So number of moles will be the given mass upon molecular mass. So we have the given mass from the question, which is 12.6 divided by 84. And the answer will be 0.15 mole. The third step says determine the number of moles of carbon dioxide formed. So we'll go to see the ratio from the reaction given, and from here we can see the ratio between the sodium hydrogen carbonate and carbon dioxide is 2:1. That means every 2 moles of sodium carbonate produce 1 mole of carbon dioxide, half of the value of sodium hydrogen carbonate. So in that case, if we calculate the moles of CO2, so moles of CO2 will be 0.15 divided by 2, that is 0.075 moles. And the last part is calculate the volume of carbon dioxide formed at the room temperature and pressure. So volume, calculating the volume of any gas, we know 1 mole of any gas has a volume of 24 decimeter cube at RTP, that is room temperature and pressure. We have 0.075 moles. So what will be the volume? 0.075 multiplied by 24, and the answer will be 1.8 decimeter cube. In this question, the equation is given for hydrated barium chloride crystal. When they are heated, the water is given off and you get anhydrous barium chloride plus X molecules of water. And during this experiment, you have to determine the value of X in this formula. Now, the values which are given over here is that the barium chloride .xH2O, which was used in the experiment, that BaCl2.xH2O is 4.88 grams. And when it is heated and the water is given off completely, the leftover BaCl2, that is the anhydrous form, the anhydrous form have only 4.16 grams. The molecular mass of barium chloride BaCl2 is given 208, and for water it is 18. Determine the value of X with the following step. The first step is to calculate the moles of barium chloride. As we know, moles equals to the mass used upon the relative molecular mass of the compound. So the mass of the barium chloride, we will be using this anhydrous mass, which is 4.16 divided by 208, and the number of moles which will come out as 0.02. The second step say calculate the mass of water which is given off. So how much water is given off? Water, for mass of the water, we will subtract the anhydrous value of barium chloride from the hydrated one, that is 4.88 minus 4.1, and we will be getting the value as 0.72. Now calculate the number of moles. Again, we will be using the same formula to calculate the moles of water given mass upon the molecular mass. So the given mass is 0.72. The molar mass, the relative molecular mass is 18. So dividing it by 18, we will get the value 0.04. Now they ask you to determine the value of X. So that is a ratio between the moles of BaCl2 and water. So BaCl2 ratio water, so 0.02 ratio 0.04, and that will give you a value, the ratio of 1:2. So the value of X will be 2 over here in this formula. In this question, when solid copper nitrate is heated, copper oxide, nitrogen dioxide, and oxygen gas are formed. The equation is given. Calculate the volume of nitrogen dioxide formed at room temperature and pressure when 4.7 gram of copper nitrate is heated using the following step. Now the first step says calculate the number of moles of copper nitrate. Calculate the mass of 1 mole of copper. So mass of 1 mole, it refers to the molar mass of the substance. So the molar mass of the copper nitrate, that will be the atomic mass of copper, which we can take approximately 63.5, plus for nitrogen we will be taking 14, plus oxygen 16 multiplied by 3, that is 48, and the entire thing will be multiplied by 2. This will come out as 187.5. So we got the mass of 1 mole of copper nitrate, that is the molecular mass of copper nitrate, 187. The second step says calculate the number of moles of copper. So moles of copper nitrate will be molar given mass upon molar mass. So the given mass for the copper nitrate from the question, we can say that is 4.7 grams. So 4.7 grams divided by the molar mass 187.5, and the number of moles will come out as 0.025. The next step is determine the number of moles of nitrogen dioxide formed over here. From the reaction, we can see the ratio between copper nitrate and nitrogen dioxide. It is 2:4. Or I can say in a simplified manner, it is 1:2. So every 1 mole of copper nitrate is producing 2 moles of nitrogen dioxide. So in that case, the number of moles of nitrogen dioxide will be just double of whatever moles we have for copper nitrate. So moles of copper nitrate, if we multiply it by 2, we will be getting the moles of nitrogen dioxide, which will come out as 0.05. The last step is calculate the volume of nitrogen dioxide at the room temperature and pressure. We know the 1 mole of any gas at RTP will have 24 decimeter cube volume. So for 0.05 moles, how much will be the volume? 0.05 multiplied by 24, and the answer will be 1.203 decimeter cube. In this question, the reaction is given zinc carbonate reacting with nitric acid, giving using water and carbon dioxide. The question says a student found that 2.5 gram of zinc carbonate requires 20 centimeter cube of dilute nitric acid to react completely. Calculate the concentration of dilute nitric acid using the following step. The first step says calculate the mass of 1 mole of zinc carbonate. Mass of 1 mole of zinc carbonate, that means you have to calculate the molecular mass. Mass of 1 mole of zinc carbonate, which will be equal to the molecular mass of the zinc carbonate. So for zinc, then we will use 65, carbon 12, and oxygen 16 into 3, 48, and the answer will come 125. Then we have to calculate the number of moles of zinc carbonate which are used in this reaction. So moles will be equal to given mass upon the molecular mass. Given mass from the question, we can see whatever the mass of zinc carbonate is 2.5 grams. So 2.5 grams divided by the molecular mass 125, which will come out as 0.02 moles. The third step says to calculate the number of nitric acid. So from the reaction, we can see that the relation between the zinc carbonate and nitric acid is 1:2. That means whatever amount of zinc carbonate takes, double number of the moles of nitric acid are required. So moles of nitric acid will be 2 times moles of zinc carbonate, which is 0.0. So the answer will come out as 0.04. The last step is calculate the concentration of nitric acid. Concentration of nitric acid can be calculated using the formula concentration equals to moles upon volume in decimeter cube. So moles we have from here 0.04, and the volume is given in the question. If you see, it is given as 20 centimeter cube. So what we need to do, we have to change it in decimeter cube. So 20 divided by 1000, that 1000 will come on the top like this, and the final answer will be 2 decimeter cube. Now this last question is somewhat similar to what we have solved previously. So this is your test time. Do it yourself, and in case you are not able to solve it, or you have some doubt for this particular question, you can put a comment, and then I'll be sharing the solved answer as well. Thank you.